2020, streaming live on YouTube. Today is indeed a very special occasion because we are also celebrating 25 years of the GONG project. GONG, or the Global Oscillation Network Group, is one of the flagship synoptic programs at the National Solar Observatory, USA. 2020, streaming live on YouTube. And we at USOPRL are privileged to be a part of this important global partnership. To mark this event, we are honored to have a stellar panel of speakers from NSO, and we welcome them all to today's function. Before we begin, I would like to add that there will be a brief selective Q&A at the end of all the talks, and I would encourage you to type them out in the YouTube chat box. I now request Dr. Anil Bharadwaj, Director PRL, to welcome the gathering. Sir.
Namaskar. A very good morning to all my colleagues of Udaipur Solar Observatory, Physical Research Laboratory, and all who are joining us live on the YouTube. And a very good evening to our colleagues from National Solar Observatory in US. A very warm welcome to all to the Foundation Day celebration of Udaipur Solar Observatory of Physical Research Laboratory, PRL. PRL was established in the year 1947 by Dr. Vikram Sarabhai, who is the father of Indian space program. And the year 2019-2020 is the birth centenary year of Dr. Vikram Sarabhai. USO, or Udaipur Solar Observatory, was founded in the year 1975 by the great effort of Professor Arvind Bhatnagar, and situated in the middle of the Fateh Sagar Lake. USO is a premium observatory of India and is a leading center for solar physics and helioscience. It houses observatories for looking at the sun, starting with the SPAR telescope, and now we have MAST, which is a multi-application solar telescope, and we have E-Callisto, which is looking at radio emissions of the sun. This year, that is 2020, also marks the 45 years of establishment of USO. And this year also marks the 25 years of operation of GONG, that is Global Oscillation Network Group, instrument at USO of Udaipur. This is one of the 6 sites in the world for making observations of the sun. I'm extremely delighted to have colleagues from USO, the 4 colleagues who are live on this program and who have been greatly associated with the GONG project. I very warmly welcome Dr. John Liebecker, Dr. Jack Harvey, Dr. Frank Hill, and Dr. Alexei Pestov. And I also thank them for staying up late in the evening as per US time and joining us live on this program, as well as today's celebration. All of them have visited Udaipur and the GONG facility at Udaipur. And Frank Hill visited us early last year, whereas John has visited us quite some time back. So they all must be having very good memories, or sweet memories of their visits to Udaipur as well as to Udaipur Solar Observatory. USO has been operating GONG for last 25 years, making observations, which was upgraded to GONG++ or double plus program in the year 2011, and which also provides now the full disk chromospheric observations of H Lyman. GONG has great contributions from colleagues from USO, starting from its first director, Dr. Arvind Bhatnagar, and then Dr. Ambastha, Dr. Sushant Tripathi, Dr. Venkatakrishnan. And it has been used extensively by PhD students working at USO, which includes, of course, Shibu Mathur, Brijesh, who are there live on this program, Sanjay Gosai, Ram Ajor, Maurya, Vima Reddy, and even now, students who are doing a PhD at USO are making use of this observatory. And this GONG observatory is also going to be quite useful with respect to India putting up the Aditya L1 mission, which is an Indian solar observatory in space, coming up next year. And it will be extremely useful for doing space weather studies. So my colleague, Dr. Brijesh Kumar, will be covering the contributions of USO with respect to GONG. And at this juncture, I once again welcome you all to today's program. And I convey my very best wishes and greetings to all of you on the Foundation Day of USO. And my colleagues from USA, thank you all for joining us live. Thank you very much.
Thank you, sir. I now request Professor Nandita Srivastav to introduce our speakers to the audience.
So, very good morning to all of you in India, and a very good evening to all participating from the United States, basically from the National Solar Observatory. It's indeed a great honor and privilege for me to introduce today's speakers. I would like to first introduce you the first two speakers, Dr. John Liebacker and Dr. Jack Harvey, and then we would have their talks, after which I will introduce the remaining speakers. I think that would save us some time. So the first speaker of this morning is Dr. John Liebacker, who is presently an astronomer emeritus in the National Solar Observatory of the US. John received BA from Howard College and MA and PhD in astronomy from Howard University in 1971. His research interests include the study of dynamics of the solar atmosphere and interior. John worked as a postdoc with Dick Thomas at the University of Colorado, Gila and Roger Bonnet at the LPSP in Verrières-les-Buissons, France. He worked for a number of years at the Lockheed Palo Alto Research Laboratories before joining the NSO, where he served as the director and program director for GONG. John has been an active co-investigator on several NASA missions. He worked at NSO from 1981 until 2018 when he superannuated. He is a visiting scholar in the Lunar and Planetary Lab of the University of Arizona and a chercheur associate at the University of Paris-Saclay Institut d'Astrophysique Spatiale. John has served as the editor-in-chief of the Solar Physics Journal for the last 15 years. He has also served as chairperson of the Solar Physics Division of the American Astronomical Society. John is a recipient of several honors, which include the 2017 prestigious Jules Janssen Prize of the Société Astronomique de France. He has an asteroid named after him, and he has also recently been included in the inaugural group of fellows of the American Astronomical Society. The second speaker today is Dr. Jack Harvey, who also has an illustrious career and is currently an astronomer emeritus in NSO. Jack received BA and MA degrees from the University of California and PhD in astrogeophysics from the University of Colorado in 1969. Jack's research interests include the study of the sun, its magnetic field, and interior. He worked at NSO from 1969 until he superannuated in 2018. He also has an appointment as visiting research scholar in the Lunar and Planetary Lab of the University of Arizona. Jack has been to Antarctica, I think 5 times, to make continuous observations of the sun with his own instrument. He also designed and developed the GONG instrument that have been deployed at the 6 stations of the GONG network. He has authored more than 250 research publications with more than 7,000 citations, and he was a past editor of the journal Solar Physics. Jack has been recipient of several awards, which include the 1991 NASA Exceptional Scientific Achievement Medal, National Science Foundation Antarctic Service Medal, the 1999 American Astronomical Society George Ellery Hale Prize, and the 2011 Arctovsky Medal of the National Academy of Sciences. A mountain in Antarctica has been named after him, and he also has an asteroid named after him. He also was recently included in the inaugural group of Fellows of the American Astronomical Society. I am grateful to both Dr. Leibacher and Dr. Harvey, who have agreed to give talks at a very short notice today. Dr. Leibacher will be speaking on the origin of the partnership of GONG with USO, and Dr. Harvey will speak on the technical aspects of the GONG project. Dr. Leibacher, please.
Let me unmute. Can you hear me okay?
Yes.
Okay, excellent. Let me take this silly gong hat off. Let me apologize at the outset that I have some sort of a ear infection, so I don't hear very well. And so I may be shouting. Cover your ears if I'm speaking too loud, or I may have a hard time hearing questions. So one moment to get queued up here. So, namaste, namaskar. Thank you so much for inviting me. It's a very auspicious occasion, and we're delighted to be able to share some of our recollections and our thoughts for going forward. I have the official GONG t-shirt on backwards, so you can see the logo, which is on the screen. The message from that logo is that we have the whole world, all 6 sites, plus the network headquarters in Tucson, now in Boulder, working together to make this wonderful thing go forward. And I note, while we have the logo up there on the screen, the pride of position of Udaipur in the upper top right. Thank you again, Nandita, for this invitation. Thank you, Rohan, for helping us, and Professor Bhararaj for your very nice summary of GONG. My title should really be GONG in the USO, the first 2 decades. And Jack will share the effort of getting started with GONG, and then Frank will carry on in terms of what's happened most recently. First of all, let me again repeat my pleasure at being part of this Foundation Day. We're under quarantine of sorts here, or at least I've been working at home now for many months, so I wasn't able to go into work to get to historical files. And so what I'm going to show you are just some photographs from my personal collection. So it's maybe way too personal. I appear in too many of the pictures, if you will. But I'd like to use those pictures to make 3 points. One is that it takes an enormous dedication of a very large partnership, working very close together over many years to make something as complex and as sophisticated as GONG work. All the way from the brave fellow in Udaipur chasing snakes away from the shelter to the director of ISRO and all of us in between. The second point is that the network only works if all of the sites and the central facility and the scientific community work together. That is to say, the logo conveys that there's a network of 6 sites with the headquarters. Our view was that it was like a chain. Without one link, the chain was no longer there, and so we all needed each other to carry forward. And so it was a really fundamentally viewed and operated as a partnership. The last point is that we got started basically for 3 years as an experiment, a little bit like a neutrino measuring experiment. We wanted to observe for 3 years, 1,000 days, to measure the frequencies, to address the neutrino deficit problem in those days. During that time, additional discoveries were made. The sun was variable, and so we were able to garner the support from our partners, the partner sites like Udaipur and our sponsors and the community, to go from the original GONG to what we call GONG++ with higher resolution, constant magnetograms, to do new science after that original experiment had been accomplished. So it became more of a facility than an experiment at that point. And now we've gone even beyond that by adding additional complementary facilities. I mentioned the continuous magnetograms, but also continuous H-alpha imagery, which serve a far larger community. And this should continue into the indefinite future. We've observed now for 25 years a Hale cycle in terms of the 2 sunspot cycles of solar activity. I think with the new enhancements that will be talked about later, we should be good for another Hale cycle. And the community is there with us. In any case, let me get to the pictures. This is the Silver Jubilee of GONG at Udaipur, but GONG and Udaipur actually started 10 years earlier at the IAU General Assembly in Delhi in November 1985, 10 years before we actually started observing. Arvind and I were there together. We worked on a proposal for support, which was successful, and the rest is history, as they say. Actually, let me say that the relationships that made GONG possible, that is to say, initially between Arvind and those of us in NSO, really started much earlier on. And Jack Harvey was part of that. And Arvind was in Big Bear for a number of years, working with Bob Howard and Bill Livingston. So as usual, I've taken half of my time on the first slide. We'll go through the pictures now very quickly. I couldn't resist, if you go to the second frame, Rohan. This shows the GONG Foundation. Since it was Foundation Day, I couldn't resist the bad play on words to show this picture where we were pouring the foundation for the GONG instrument. You can see the lake in the background. Arden Petrie was the designer engineer wearing a hat there, who was responsible for this. But you see Arvind straight in front, Sushant Tripathi, Ashok, and Sudhir Gupta, who will appear many times further on. Sudhir was, along with Arvind, a very, very major player. Rohan, if we can go to the next slide, which shows our founder. We're talking about foundations. Arvind with his irrepressible smile there in his home. Those of us who've had the pleasure of visiting Udaipur, particularly in the early days, or many times there in his home, had pictures of his family, his daughters, but have to skip over them for the sake of time. But it was a real sense of friendship and mutual respect, a sense of a village pulling this whole thing together that Arvind personified so well. If we go to the next slide, my good friend, sadly departed Sudhir Gupta, was from the earliest days in Udaipur with the site survey, an incredibly important player. And here he is looking very anxiously over my shoulder. He looks like he's smiling, but he's afraid that I'll hit the wrong key or something. Sudhir was a major player or principal, visited us here in Tucson, and is sorely missed. Incorporated the spirit of the collaboration. Here's the GONG site survey instrument on the roof of the old office building. Some of you, Nandita, may remember that before the new laboratory was built. I have fond memories of nights spent there. The next slide shows site survey site Ladakh, in Leh. Arvind was conducting an infrared survey up there at the time. And I went up there to look at it as a potential gong site, with the advantage of being on the north side of the Himalayas and being less affected by the monsoon. We decided not to put the instrument there. We didn't even put an official site survey instrument there because of logistical difficulties. But look at the sky. It's a beautiful coronal site, and we hope everything comes together for the NLST, which is just 100 kilometers or so further up from there. If we can go to the next slide. Well, Arvind was, of course, our founder. We don't want to forget Venkat in our brief flyover of the history. He was a very, very strong supporter for many years. And here he is. Again, I apologize for the personal touch of the pictures that were in my file here at home, in my office in Tucson. You can see on the upper bookshelf there a beautiful silver tray from PRL that I received, which I guard as a very fond memory, and a gong that I purchased at the Tibetan market in Delhi. That's still with me. We go to the next slide. So I tried to emphasize it takes an enormous number of people to make something like this. And here's a season's greetings card that we put out on the occasion of Gong Plus, where you can see people from all around the world, from all of the sites. You see Sushant there on the upper row. You see Shaman Latak on the right side at 3 o'clock there. Shaman took great care of everyone and was a real part of the family. I hope he's well. You see Puja in the bottom there, and Sudhir again off on the left, and people from all of the other sites. You see Jack Harvey there. Lana Britannic in the upper right. See who else is there. Oh, and Sang in the bottom there. Right. So again, the emphasis here is, I would say, family, but village. A group of enthusiasts working very, very closely together. If you go on to the next slide, here's U.R. Rao and Girish Agrawal, predecessor as director of PRL. We were all together in Udaipur for the Silver Jubilee of USO. We're celebrating the Silver Jubilee, if you will, of Gong this year. This was the Silver Jubilee of USO in September 2001. The U.S. Embassy wasn't very happy that I made the trip, but it was really it was a wonderful occasion, and I was very pleased and privileged to be part of the Jubilee celebration there. You can see Sudhir in the background as always. Moving right along, I think we have 2 more slides. This is a picture of the shelter with Brajesh there and Ashok and Venkat in the background and Sudhir perpetually there, and a group of people from the U.S. Congress. And the gentleman in the middle is Kurt Suppley. He was the director of the National Science Foundation legislative program. So he was our intermediary between the National Science Foundation and Congress. They all came at one of the breaks in Congress to visit a number of facilities in India, and they chose to come to Udaipur. We had very, very strong support from these people, as we did from Professor Rao and Professor Agrawal in keeping the support for going. At about the same time, you almost had Bill Clinton coming to visit Udaipur. He was coming to India for a visit and wanted to tour some sites with U.S. involvement in India. Our NSF contact for international affairs, Marjorie Luik, went to the White House to discuss options with him, and they wanted to come to Udaipur. But fortunately for us, the runway is just a little bit too short for a 747, so we didn't have all the security hassles. Next slide shows the canonical picture of the turret with the temple behind. There's Sudhir as always, and saying, our main man for the maintenance of the GONG network. Again, making sure I don't do anything untoward. The whole GONG network exists because of compelling science arguments, and initially to understand the solar neutrino deficits, and now a much broader range of scientific topics. When the GONG first results came out, we got the cover of Science magazine, and Arvind and all of the site principals were co-signatories on those articles. And so throughout, and any article that's published in Solar Physics or the Astrophysical Journal using GONG data always cites the USO. So it should appear in your publication list. Now I think the real last picture is an example of the science from GONG. This is a cut from the poles to the center, from the equator to the center on the bottom, pole to the center on the top, showing how the sun rotates deep below the surface. I chose this as an example of the science because it comes from India. It's the work of our friend Antia at the Tata in Mumbai. And I think this is emblematic, to me at least, of the hopefully very positive impact that GONG has had throughout Indian science, and a number of people across India who have been involved with it. Shravan Hanasog is now on the permanent staff at TIFR. Paul Rajaguru at the IIA in Bangalore. DB Nandi at Kolkata. In just the last 25 years, very impressive number of new institutions have appeared in solar physics. The Ayukan in Pune, Deepu Banerjee now in Nainital, solar physics in other places like Lucknow. And I hope GONG has brought honor and visibility to the solar physics program at Udaipur. So this really is the last picture. And it's the GONG shelter, but it's an Aussie, Paul from Melbourne, from Monash, and Paul Cali was at a meeting someplace else in India and wanted to make a visit to Udaipur because the GONG shelter was there. And a number of other important solar physicists who have visited India have come to Udaipur because of that. Christian Dalsgaard was there one time with me, Judy Karpin, Wolfgang Kalkofen. You have the guest book, so you know it better than I. Anyway, I've talked far too long. Thank you so much. Best wishes for another 25 years, another hail cycle of very important, exciting, and compelling science, and the important satisfaction of working so productively together with wonderful collaborators. Dhanyavad, shukriya.
Thank you, John, taking us down the memory lane. I now invite Dr. Jack Harvey for his talk. Thank you.
Good morning, everybody. I wonder if I can share my slides. I think. I hope it is. There you go. Okay. It's very good to be back in Udaipur, even if it's just virtually. I'm sorry that I can't be there in person. I'm retired now, but I continue to work part-time with one of your illustrious former members of the staff, Sanjay Bhusan. And I have to say it's a real pleasure to work with him. During my long career, I've had the good fortune to encounter many people from India. The first one was particularly momentous. I was a student at the University of California, going from one classroom to another outside, and I ran into a gentleman from India, very surprisingly. It was Jawaharlal Nehru. I was about a meter away from him. There was nobody else around. I was, of course, starstruck. I didn't say anything, but I had to get to my class. It was wonderful to see him. Also, as a student, I encountered Chandrasekhar. And then as a young staff member at the National Solar Observatory, I met Venu Patlu and, of course, his student, Arvind Bhatnagar. With Arvind and I and some others, we studied the oscillations of the sun in the early 70s in the McMath telescope at Kip Peak. And I had a great time with Arvind. We had a lot of fun and we got some good science out of it. Let's see. I managed to get to the Udaipur site in '96 when there was the Golden Jubilee workshop of PRL. And there I am with Arvind by the Gong tour. And a number of papers were presented at that meeting. I was there to maintain the instrument, but also to give a couple of talks. So Arvind gave a talk on international collaboration of the Global Oscillation Network Group. And I have to say he was a real motivator to the whole worldwide community. He was so enthusiastic about doing it that it made it reasonably easy to convince other observatories to join the Gong. Now, I described the Gong instrument and some of the early science that was done with it. Now, don't worry, I'm not going to bore you with a lot of technical details because the paper that I gave there is still pretty good. Even after these years, it's a pretty good description of the instrument. I'm supposed to talk a little bit about the technical details. And I'll give you the thumbnail sketch. Gong is a telescope and a camera. It records images of the sun. And its goal is to make precise measurements of the solar surface motions caused by pressure waves trapped inside the sun. The method that we use is phase shift interferometry, which is widely used in technological applications and is very handy for this kind of work and has proven to be quite a successful technique. As John mentioned, it was designed to last for 3 years, and so we didn't put a huge amount of energy into making it a long-lived device, but here we are 25 years later. It's still going. The noise level was aimed at 1/10 of the solar background noise. The technology that we used was 1980s and early 1990s. Today, the instrument could be greatly miniaturized. In fact, maybe later we'll hear about a proposal to put a gong-like instrument into space, weighing about 12 kilograms. As John has emphasized many times, Gong would not have been successful if it were not for people like Sudhir and many others around the world, especially at USO, who keep the instrument running. Here we are half the world around, away from the instrument. We can't touch it, so it's really valuable to have people, knowledgeable people, dedicated people to keep the instrument running. It's a complex instrument, far beyond its design lifetime, but without the careful attention from alongside collaborators, we certainly wouldn't have had the success that Gong has enjoyed. And I can't emphasize enough that during the development of the Gong instrument, the director, Arvind, was so enthusiastic in helping us with so many aspects of the instrument and the science behind the Gong that, again, it would have been difficult to proceed without some of his contributions. In particular, he scouted around India for excellent calcite crystals and brought them personally to Tucson, to my lab, for use in the GONG narrowband filters. So thank you to Arvind and to people in India for providing those resources. I worked with Arvind and other people did in the U.S. solar community since the early 1970s. So he was well known to our community and a favorite. I'm going to turn in my last two slides to some really personal things. To me, science is greatly enriched by the personal contacts and friendships that we can establish with our colleagues. And Arvind and others at USO have certainly been excellent examples of that. Here, Arvind is presenting a staff-signed photo from the USO to a retiring director of the National Solar Observatory, Bob Howard, in Tucson. Bob was one of my mentors. Arvind, I don't think of as a mentor, but more of as a scientific collaborator and a great friend. And right behind the photo is Phil Livingston, another one of my mentors, and Molly Howard, who was a great hostess and many, many visitors. And we had many good occasions in Tucson when Arvind and others from India were visiting. Finally, my wife Karen was a co-investigator on the Japanese-US Yopo space mission, which took us to Japan several times. And I have to say it was a great pleasure and not a complete surprise when we walked into the science operations room of Yopo, and there was seated Arvind. I mean, what a pleasure. We travel around the world and we keep encountering Arvind. It was great. So we had a lot of fun in Japan working on the Yopo data with Arvind. We had many social occasions, and this photograph is unfortunately our last meeting together at our home shortly before Karen died. We were both very pleased to see him and to have the occasion to recall past times together. I want to take this occasion to thank the USO staff for a quarter century of productive and friendly collaboration. It has been a great personal honor for me to work with you. Thank you so much.
Thank you, Jack, for a nice presentation and talking about personal friendships which enrich science and social life both. Thanks once again. I now move on to the introduction to our main speaker, Dr. Frank Hill, who has agreed to give the Foundation Day lecture. I'm very happy and honored to introduce him. Dr. Frank Hill received his PhD from the University of Colorado in Boulder in 1982, working with Dr. Judy Tumray as his thesis advisor. He joined the staff of Sacramento Peak Observatory in Sunspot, New Mexico, and moved to Tucson, Arizona in 1984 after the National Solar Observatory was founded. In fact, he got involved with GONG project from its very beginning, carrying out the site survey from 1985 to 1993 that selected Udaipur as one of the 6 sites of the GONG network. He then became the data scientist and finally the associate director for the NSO's Integrated Synoptic Program, NISP, comprising of GONG and SOLIS. He has 333 papers and articles to his credit, mostly in helioseismology. Frank invented the ring diagram analysis of helioseismology, and he follows the evolution of the solar torsional oscillation with great interest. Frank superannuated in March this year. I would like to inform that when I contacted him, he took personal initiative of inviting the other speakers of today on our behalf and is solely responsible for making today's program so exciting. He will give the Foundation Day lecture on transition of partnership of GONG to today. Frank's talk will be followed by Dr. Alexei Pevtsov's talk. It's a pleasure again for me to introduce him. Dr. Alexei Pevtsov is the Associate Director for the NSO Integrated Synoptic Program, NISP. He received MS degree from Leningrad, now St. Petersburg State University in 1984, and PhD in heliophysics and physics of the solar system from the Institute of Solar Terrestrial Physics, Russian Academy of Sciences in 1992. After his PhD, he worked at the Institute for Astronomy, University of Hawaii, and then at Montana State University. He then joined the National Solar Observatory in 2000, and from 2005 till early 2009, he served at the NASA headquarters as the program scientist for 2 programs and 5 heliophysics missions, which include Hinode, RESI, SDO, SOHO, and TRACE. Upon returning to NSO, he served as the program scientist for synoptic optical long-term investigations of the sun, which is SOLIS, and later as the program scientist for atmospheric section of NISP. He has authored more than 200 publications. He is a member of the American Astronomical Society, AGU, IAU, and COSPAR. He is serving as a co-chair of IAU Interdivision B and E Working Group on Coordination of Synoptic Observations of the Sun. Today, he is going to speak about the future programs of NISP. At the end, my colleague Dr. Brajesh Kumar will be presenting the highlights of contribution made by USO to the GONG project. He is presently taking care of the GONG instrument at Udaipur. He has done his PhD using GONG data in 2007 under Professor Venkat Krishnan's supervision. He has several collaborations with NSO on the GONG program, NISP program, National Solar Observatory and University of Colorado Boulder, with CEA Saclay, France, with Instituto de Astrofísica de Canarias, Spain, and Space Science Institute in Boulder, and also Indian Institute of Astrophysics in Bangalore. He has received the ISRO Team Award for the Multi-Application Solar Telescope in 2015 as a team member. With this introduction, I now invite Dr. Frank Hill for the Foundation Day lecture. Frank, please.
Thank you very much, Nandita, for that glowing and over-the-top introduction. Let's see now if we can find my presentation. There it is. Is that visible?
Yes.
Yes.
Good. So the topic of this talk is the transition to today, 25 years of USO, PRL, and GONG. Here's an outline. I'm going to tell you a little bit about the site survey, which is ancient history, but some people probably don't know. Some memories of the 93 school that Nandita shows some pictures of, memories of the deployment, very brief thing on some science, and then a section on GONG and space weather, which is pretty much the future, I think, of this particular facility. So the site survey, we started, me and Gordon Newkirk at HAO at the time, we started with a simple 4-parameter model of climate, just the mean probability of a clear sky, how long it is in days between cloudy periods, and those numbers for January and July, coupled with a gamma probability distribution, combined with the geographic location and the daylight variations for various sites, did a Monte Carlo of many, many networks and found that the 6 sites were sufficient to lower the first daily side lobes in helioseismic power spectra to a part 10 to the 3. This was our main goal here. GONG was designed for helioseismology, and the real problem of the day of that day with Udaipur seismology was the fact that the sun would set on you at a given site, of course, every day, and that put horrible, horrible artifacts into our power spectra. One way around that was a network. Other ways were going to Antarctica, like Jack did, or go to space, like we have also done as well. But with that, we found that 6 sites were sufficient to get to where we wanted. And as you can see from the plot, I hope you can see my cursor. The duty cycle, which is on the y-axis, is a function of the number of sites. On the x-axis, tends to asymptotically flatten out at around 6 sites. So you really don't gain much by adding 7 to getting more sites to that, at least in terms of a duty cycle. As John alluded to and showed you a little picture of the instrument in Udaipur, here's a better picture of it in Tucson. It was just a thermopile per heliometer for Eppley. John did all the software to program our acquisition computer, which was the Mighty HP25 programmable calculator. Mighty it was. Data was returned on many cassette tapes, many cassette tapes, still in my office here in Boulder, believe it or not. The data looks something like this. This is a week of data from Tucson in November of '84. You can see this is a nice clear day here, except for a little bit here. Here's a really nice clear day, bad day. And then we analyzed all this data from all the sites. We tested 15 sites. We had 192 possible networks from those 15 sites, but only 16 were reasonable ones, by which I mean distributed in longitude enough that you actually saw the sun all the time, as opposed to having everything at one longitude. We carried out some fancy principal component analysis to identify groups of sites related by conditions, and we chose the best network. It didn't necessarily comprise the best sites that we tested, but it was the best possible network, and that's really what we were after. And a linchpin that showed up in every possible good network was Udaipur. And so here's the final network we ended up with: Udaipur, Learmonth, Australia, Mauna Loa, Hawaii, Big Bear, California, Citayo, Chile, and Tenerife in the Canary Islands. So that was how the site survey occurred, and that's how we ended up with Udaipur, which is a really good thing because like I said, it's a key reason why GONG has worked all these years. So in 1993, which is after we selected the sites, which was in 91, but before we did the deployment, which was in 95, we had a helioseismology school that we ran in, I think it was January, and I think it was in Ahmedabad. Nandita can correct me if I'm wrong. It was my first visit to India. There were lectures by these guys, and I think I have Paterno in there incorrectly. There are others who I can't remember. This was apparently a successful event because it convinced Sarbani Basu to enter the field. So I think that was a good thing. She has gone on, as you all know, to be a very prominent helioseismologist and astroseismologist as well. Here are some pictures from the school. Let's see. Let's go down the right side first. Here we are. This is after the school in Ahmedabad, and we are on we've all taken this trip up to Udaipur, and we are on the boat. It looks like I was coming back from the visit to the island at the moment. I think that's Debbie Prasad there. That's Tim Brown. That's me. I think that's Debbie Prasad again. And here's me, and here's Arvind. So that was our boat ride back, and I don't think anybody fell in, as far as I know. As far as I know, no one has ever fallen in, at least the times I've been there. I remember other meetings where somebody had fallen into a lake, but not there. In the central column here, we have a visit to the old telescope. This is way before MASS, of course. Here you can see the legs of some prominent solar physicists. Here you can see Jan Christensen Dalsgaard. I think this is Nandita. I think that's Arvind there. That's Douglas Goff, and that's me. And then there's a picture of some equipment, thank goodness, without any people in it. We also did touristic-y things. Here, I think this is a picture of us at the well near Ahmedabad. Here we are having a snack on the island with Yuri taking notes. He always took notes. And here's a visit to Ranakpur, it looks like to me. Ranakpur, one of my favorite places to go. whenever I go to visit Udaipur in India. So that was the 1993 helioseismology school. And then the next major thing in my world for this was the GONG deployment. That was the year of 1995. We put out all 6 sites in a year. We had 2 deployment teams. The whole deployment began with Tenerife, the Canary Islands, in January of that year. Udaipur was the 6th and final site to be deployed. We did that for 2 reasons that I can recall. One, it allowed us to make as many mistakes as possible at the other 5 sites before we got to India. And it also allowed us to avoid the monsoon weather during the deployment. I was there for quite a while. It started in mid-August, and it was monsoon then, I vividly remember. And then the team came in 2 other groups as the monsoon wound down. And we completed the deployment on October 4th, 1995. That was when the site was up and running, and the network was taking data from all 6 sites as of that date. Here's a deployment crew. This is not at Udaipur. This is CTIO. I could not find a picture of the deployment crew at CTIO, but these are them. We have Neil Mills, who was our mechanical systems guy. Guillermo Montillo, who was one of the electronics techs. Me, optics and complaining. Brett Goodrich, our software engineer, and Sang Nguyen, who, of course, you've seen many, many times ever since. Not shown in this picture was Lonnie Cole, our electrical engineer. He actually went to every single deployment, but he never went for the whole thing. He would come later on when it was near the end, and he could make sure everything was running. So that's the intrepid crew that was there in Udaipur in August, September, October of 1995. Here is back at home base in Tucson. Here's all 6 of the instruments all lined up. And here goes the one to Tenerife on its way as the first one out of there. I think we've shown this picture a lot. Here is preparing the critical pad. John showed the lower picture earlier on. Here is even before the concrete was poured, the building of the forms, the removal of the soil from the various places. And then here is Arvind and the others doing inspecting the pour of the pad. This was a very crucial thing for GONG because it needed to be oriented north-south as accurately and as precisely as we could get, but particularly as accurately as we could get. We really wanted it to be absolutely north-south. Of course, they never were. They never are. And so this, to cope with the ramifications of that slight deviation from north-south, different at every site, has created a lot of software approaches built by Cliff Toner and others back in Tucson to try to take out and try to get the angular registration across the network solid and robust. Still a continuing issue. The hardest part of GONG, in my opinion, is angular registration of all the images. But we can do it somewhat. Finally, it's there. The shelter has made it. Here we are. It looks like it's just arrived. It looks like, I think that's Sang and Guillermo looking at the door, seeing what's what. Our ambassador car, of course, which we had to be driven around in a lot. So we made it. Here are some pictures of the installation after it is done, the original installation. You can see the original fence. Here's our hill behind us with the temple on top. I think you can see it a little bit better here. Here's a view from the lake where GONG is situated up in here. And there's a view from down the road as we leave the shelter. You also, and at the same time, about the same time, a new campus building was built for USO. There are some views of it. Really nice building, still there, of course. I really like visiting. So it was good that they got a new building out of this as well. And there was fun of the deployment too. We went to the city palace, a nice sun symbol in the middle of the building, another sun symbol and a case inside. We went to visit Ranakpur, the Jain temple, not too far away, and encountered a whole bunch of monkeys on the road and inside the temple and everything. It was lots of fun. Went to Chittagar, other places as well. And we had a great banquet at the end, celebrating everything. And then the day before we left, I was sitting next to the instrument rack, and there was a bang, and an integrated circuit flew past my nose, and the whole thing stopped. And we were like, what? Luckily, Lonnie Cole was there at the time, and he found the problem, and we all wiped our brow when we left, and it kept working also after we left. So that was excitement. And of course, you've all kept it going, thank goodness. From Nadita and Shibu, and Brajesh, and Sudhir, and Chaman, and who's this tall guy back here? How'd he get in there? Anyway, as John has said, none of this would work without everybody. Everybody is extremely important to the success of GONG. And you've all directly contributed to some major results. Here is a very short snippet of major science results from GONG and helioseismology. We know a lot now about the internal solar rotation, the tachocline, where the differential rotation changes the solid body rotation at the base of the convection zone. There's a near surface shear layer, which may have something to do with a surface dynamo if such a thing exists. We now can measure zonal meridional flows routinely inside the sun, and we can correlate them with how the activity cycle changes, and we can see far side activity, and many others. The neutrino problem, yes, that was definitely helped to be solved by helioseismology when it became obviously clear that no solar model that solved the neutrino problem also fit the helioseismic frequencies. And with that, you realized that it had to be a particle physics issue, and of course they then built Kamiokande and other detectors to find all three flavors of the neutrinos, and the problem was solved. Here's some pictures about the science. Here's an internal rotation rate contour plot in the upper left. The upper right has some far side maps showing the march of a big active region across the far side and then onto the front side. And then our torsional oscillation plot, now newly updated to the very latest, showing cycle 25 coming along nicely. Still don't know why it didn't have a rush to the poles, and we'll see what's happening. Still looks a little strange over here too, but we'll see. This is a major thing that GONG is following, and without USO's contribution, it would not be possible. And Udaipur has had a lot of GONG science authors. I did a very quick preliminary list. I'm sure I missed some people. I apologize already. But I said I went to ADS, I entered authors' names, and then used a full text search for GONG, and found that many papers have been written by USO scientists. Obviously, there's some collaborations here, so you can't just add all these up. But still, I think it's really great, and I think Brajesh hopefully will go into some more detail about some of their results. So I'm getting close to the end now. GONG and space weather has been mentioned. In 2006, we added the capability to do continual full disk line of sight magnetograms obtained once per minute. Still the highest cadence. Well, no, I guess that's not true anymore. HMI does it in 45 seconds. So still pretty high. This is of interest to the space weather community for forecasting geomagnetic events. Particularly, the data is now used by NOAA, the National Oceanic and Atmospheric Administration in the U.S., and their Space Weather Prediction Center. The UK Meteorological Bureau also uses the data, and NASA's Community Coordinated Modeling Center uses it not for forecasting, but for testing many codes that do forecasting. And thanks to all this interest, NOAA now provides a considerable amount of financial support for GONG operations, which is a good thing. This is an example of the display that you can find on the SWPC website, showing this is actually a movie. Sorry, this is a static image. It's a movie on the website. You see streamers of high-speed solar wind coming out from the sun, striking the Earth with stereo A and B. And then these are plots of the density and the radial velocity as a function of time. And these are forecasts, and when there's a big bump in the density and velocity, that's when you tend to have, you could have a geomagnetic storm if you had the magnetic field inside the CME pointing south. So that is what the GONG magnetograms are extensively used for at this point. In addition to that, in 2010, the U.S. Air Force funded the installation of an H-alpha system into the GONG shelters. It's a small little sled with a filter and a camera and some lenses that sits on the side of the main instrument with a pick-off beam. The images are 2K by 2K instead of the 1K by 1K, which is the format of the magnetograms and the Doppler images. And we get one every minute at a site, at a given site, but we stagger the time, so around the network we get an H-alpha image every 20 seconds. Currently, this is GONG's most popular data product in terms of scientific publications during the year. So that brings me to my conclusions. USO, it's an essential component of the GONG system. We would not be working without the USO site. We would not have been able to make the impact that we have. So, I mean, you all should be proud of this world-class facility that you greatly contribute to. You've also contributed to the science, of course, by doing your own research. And Nandita and Shibu have done a great job of keeping the USO on course. And thank you very much to the Physical Research Lab, of course, for the excellent stewardship of USO. And thank you again for the opportunity to speak to you on these subjects.
Thank you, Frank, for summarizing right from site survey to deployment of the GONG instrument and taking us to the science results. I appreciate your kind words about us and the contributions of USO to GONG project. I now invite Dr. Alexei Pavsov to give his talk. Dr. Alexei.
All right, can you hear me now?
Yes.
Yes, we're good.
All right, let me switch to full screen. Good morning, everybody in India. Good evening to colleagues and friends in the United States, and good day to everybody in between. Thank you for inviting me to give this presentation about the future of GONG. GONG is a part of NSO Integrated Synoptic Program, which is operated by National Solar Observatory, which in its turn is operated by Association for University for Research in Astronomy, ORA, under the cooperative agreement with the National Science Foundation. So NSO Integrated Synoptic Program has two major programs. One is the Synoptic Optical Long-Term Investigation of the Sun, SOLAS. And SOLAS is a full disk spectropolarimeter, which takes vector magnetic fields in the photosphere and chromosphere, also imaging and sun as a star. GONG is a network of 6 instruments distributed around the globe. And what I show here is the view from the north on the Earth globe, and you can see the sites, all 6 sites. In red, sites are in the northern hemisphere, and 2 sites in the southern hemisphere, and shown in yellow. And so you can see the site in Udaipur Observatory right here, and all other sites. So GONG was very successful project, operating for 25 years at Udaipur now. We currently take data in a full disk longitudinal magnetograms. Here's an example of one of these magnetograms. Actually, those are from Udaipur. Also images in white light, so you barely can see small dark sunspots, in H-alpha images. So this data are used for study and research in heliosseismology and magnetic fields and topology of magnetic fields. Using this data, we could look at large-scale flows inside the sun. And here's an example of solar rotation in change in solar rotation as a function of depth in the convection zone. And you can see that there are, clearly two shear regions that maybe that's where the solar dynamo is located at the base of the convection zone. Magnetograms from GONG are used to, for space weather, for modeling of solar wind. And here's an example of magnetic fields extrapolated up in the corona using GONG magnetograms. And you can see the complexity and open magnetic fields of polar coronal holes right here and on close field lines. Then GONG was operating for 25 years, and you can see if it's that long time series, you can see how the magnetic fields in the sun evolves over the time. And here is the panel that basically shows the blue color is a negative polarity magnetic field, red is a positive, and it's a super synoptic map. So it's over all these years, and you can see how the magnetic field of active regions dissipates and is transported to polar areas, and you can see the polar field reversal. And this is butterfly diagram for cycle 24. So active regions emerge at the high latitudes and gradually drift to low latitudes. And right there, you can see the beginning of cycle 25. So this is activity from cycle 25 that appeared around December last year. So GONG was, successfully operated for 25 years now, and while it's very successful instrument, there is a need for updates and changes in instrumentation. And so what we're doing, we're working now on a short-term refurbishment. So GONG, shortly, maybe next year, would receive new cameras, and then we also work on improvements to 0-point correction for the magnetic fields. Other part of this refurbishment is a tunable H-alpha filter, which would allow us to measure Doppler velocities. And all this data would really improve, enhance the information that we receive from GONG network. Very recently, we already did tests with one of the new cameras. So this is one of the first images, the magnetogram taken at two GONG shelters in Boulder. So we have two instruments similar to network instruments, but located next to our headquarters. And so one of these instruments operated old type camera, and a new other instrument operates a new type of camera. And you can see this is, zoom in on a central part of solar disk. Again, this is a magnetogram with negative and positive polarity shown in dark and white colors. And you can see that, new camera actually performs very well. There is a slight difference in noise level, which I mean, those are tests, very, very first tests. But so far we see very, very good performance with those new cameras. Over the last few months, we took longer time series and we actually computed, L-nu diagrams for helicosmology for intermediate degrees and high degree modes. And this is an example of one of these L-nu diagrams derived from the longer time series with new camera, and you can see that new camera is actually satisfies the requirements. So we keep working on that, and so probably next year it will be new cameras will be arriving on all sites, including one in Udaipur. So this refurbishment, this improvements to existing hardware would probably extend lifetime of GONG network by another 5-10 years, maybe longer. However, we start thinking about the next, start making plans for the next network, and based on studies that we perform with GONG instruments and SOLAS instruments, this new network is likely to combine capability of two instruments. So we probably will have large aperture telescopes on sites, maybe 0.5 meter or so instruments, and those instruments will be addressing both research and space weather questions. This work is done in collaboration with, some of this work is done in collaboration with European partners. So there is a project called SPRING, Solar Physics Research Integrated Network Group in the European Union. And we're working on a concept development. There's a existing grant now that was received by that group. Marcus Ross is a PI, and this from the Kiepenheuer Institute of Solar Physics. And this is one of the concepts that we're working as a next network that would eventually replace GONG. As other alternative, we also work in collaboration with High Altitude Observatory, HAR in Boulder, and the same concept of new network, but the working name is NG-GONG, Next Generation GONG. Again, a similar concept with large aperture telescopes, and it's right now it's just a concept development, but the key observations that we're planning for this next generation network would be vector magnetic fields in a photosphere and chromosphere. We will continue a single height helicosmology, but also we want to expand to multi-height helicosmology, explore this new area in helicosmology. The network would have several full disk imagers, and I give example of H-alpha and helium-10-830. H-alpha would be useful for observing flare activities and evolution of eruptions of chromospheric filaments. Helium-10-830 could be used for detecting and studying the properties of coronal holes. And because of the HO involvement, this network or some instruments, some sites in the network may have a chronograph. And so if the chronograph is selected to be part of this new network, not all existing GONG sites may be suitable for this new instruments. However, India does have a high altitude site, Sonahanli, so maybe that's the place for where the next generation GONG could be located. So just to summarize what I just said, that GONG is extremely successful project, and in addition to all the discoveries that were made with these instruments, GONG clearly demonstrated the importance of long-term synoptic observations. So we really need to observe sun for a long time, for several cycles, to understand some of the fundamental processes that take place in the sun. Data from GONG provided basis for numerous discoveries and helped training several generations of talented researchers. I think this is a very, very important role that GONG play in the field of solar physics. And I talk about this our plans for kind of short-term, upgrades to existing all existing GONG sites that would extend the current instruments' useful lifetime by another, probably another solar cycle. At the same time, we really need to think about building next generation network instruments that has this new capabilities, full vector spectropolarimetry in the photosphere and chromosphere, and the multi-height heliososmology. So this is all short presentation, but I think again, thank you for inviting me. And
thank you, Alexei, for updating us with the short-term and the long-term plans of which after GONG, which I think is going to promise us a bright future for solar synoptic observations. And we look forward to continue collaboration with NSO on this. I now invite Dr. Brijesh Kumar for USO's contribution to GONG program. I think he's the last speaker of today, and he's taking care of the GONG, so he's the apt person to describe our efforts in this area. Brijesh, please.
Namaste, everyone. Am I audible and the slide is visible?
Yes.
Okay.
Go ahead.
So it's my great pleasure and privilege to speak on this occasion of celebrating USO's Foundation Day and 25 years of GONG at USO PRL. And here I will be showing some glimpses of USO's contribution to the GONG program. As you can see, this is the island observatory of USO, housing that MUST telescope here in this under this dome. And this building is housing the SPAR telescope. And beside here, this is the Udaipur GONG site, which is in the main office campus of USO. And I'm glad to mention that I am associated with the GONG project and have been a member of the GONG operation team since last more than 20 years. So here I'm going to show you some glimpses of USO's contribution to the GONG program. This GONG system remains on 24/7, and hence the GONG operation team at USO, we have to be watchful all the time, round the clock, for receiving any alert call from the GONG system on our cell phone from the health monitoring system of the GONG. So we remain hooked up with GONG all the time. And as Frank has mentioned, that apart from the operations, USO members have also significantly contributed to the science achievements of the GONG. So in the next few slides, I will be showing some of the highlights of the science results from USO. So using the continuous observations from GONG, it was possible to study the global frequency changes with the solar cycle. And here, the global oscillation frequencies obtained from the GONG observations were analyzed over a period of 4 years during the ascending phase of solar cycle 23. And the results show that the temporal evolution of global frequencies shows changes with the progress of the solar activity cycle, which is shown here by this plot, solid line with the squares. And this solid line is for the evolution or variation in the sunspot number, while this dashed line is for the variation in the 10.7 centimeter radio flux. These two are the indicators of the solar cycle, and as we can see that the global frequencies are varying along with the solar cycle. In this work, the effect of the strength of magnetic field was investigated on the on the solar oscillations in the localized regions on the sun. And for this work, a time series of acoustic velocity signals from GONG Dopplograms were analyzed in localized magnetic concentrations with varying field. And the results show that the power of the P modes or the oscillations decreases with increase in magnetic field strength in the 5-minute band, as it can be seen here in this plot, that in the 3.3 millihertz or 5-minute band, the power of the modes is decreasing with the increase in the mean magnetic field in the magnetic concentrations. However, it was also seen that there is a transition at nearly 5 millihertz. Here, there is a transition at 5 millihertz, which is the acoustic cutoff frequency of the quiet photosphere. And this gives the signature of the magnetoacoustic waves in these magnetic concentrations. In this work, the mode characteristics, which are basically the frequency, amplitude, and width of the oscillation modes, this was investigated in flaring active region. So here, this was studied in the flaring active region, NOAA 10486, using local helioseismology technique, the ring diagram technique. And as it has been told that Frank has actually has given this technique of ring diagram analysis. So using the ring diagram technique, they studied the frequency, amplitude, and width of the modes of acoustic oscillations in the flaring active region. And the result shows that the relative difference in the mode amplitude or the power between active region and quiet increases on the flare day, on the day on which a huge flare of X17.6 class and 4B importance happened with respect to the flare day, and it can be seen in these plots. The relative difference in the mode power is higher on the flare day with respect to the pre-flare day, whereas the frequencies and the width of the modes are not affected during this period. This was a study related to the behavior of horizontal flows beneath flare productive regions. So 3 regions were selected, NOAA 10484, NOAA 10486, and NOAA 10488. And this active region was dormant, whereas this active region was highly flare productive, and this one was flare productive, but comparatively lower than this one. So the results showed that the meridional velocity V and in NOAA 10486 showed a steep gradient below 4 megameter depth, which can be seen here in this active region, the meridional velocity, and also the zonal velocity. It also showed this kind of pattern beneath the active region. And whereas this is the dormant active region, which is not showing such kind of flows beneath, and this was little less active, and you can see the scale of changes which are seen here in this active region. This was another study which was related to the pattern of helical flows beneath flaring active regions. So in the left panel here, this shows the 3D view of velocity flows beneath the active region, same active region 10486, which was people were calling it super active region, which gave large flares during its passes on the solar disk. And this is the quiet region on the sun. So one can see here that in this flare productive active region, the flows beneath are helically twisted. And with respect to the quiet, this is quiet, and this is beneath this active region. So one can see here that the zonal, this is zonal velocity and this is middle velocity, and the gradients are very high, and we change sign at a depth of something like 3.3 to between 3 and 5 megameter, and this is associated with the magnetic activity. Then the effect of large flares on the global modes of the sun were investigated in this work, and for this disk integrated velocity signals from GONG were utilized to study the flare-induced global waves in the sun during this same flare, X17.6 class flare of 28th October 2003 in the NOAA active region 10486, which happened. But this is for the disk integrated velocity signal, which is the penetration of the whole disk. So the results show that the velocity signals are enhanced significantly during the flare, which is seen in the power spectrum here. The dashed line is for the pre-flare power spectrum, whereas the solid line is for the during flare power spectrum, and signature of high frequency oscillations were seen in this comparison. This was another work which was related to the effect of flares on the localized regions of the sun in terms of the velocity flows. So for this, the active region NOAA 10930 was selected, which produced a class X3.4 flare on 13 December 2006. This is the intensity map of this NOAA active region, and this shows the RMS velocity map of the same active region during the flare, spanning the flare. And one can see these locations P and K in the penumbral region of this sunspot, which are showing large velocity flows in the penumbral region during the flare. And now this is and this was the most remarkable thing, was that these enhancements were away from the flare-driven locations. So it means that these are not affected by any artifact of flare. So then now these enhancements are being interpreted in terms of the role of the magnetic jerk, which happens during the flare in energizing these velocity flows. In this work, the power or amplitude modulation of the global modes have been studied during the progress of the solar cycle. And for this, again, the disk integrated Doppler observations from GONG were analyzed for the solar cycle 23 during the phases of maxima and minima. And this is the phase of maxima. And these oscillations represent the global low degree modes, which are seen here, the velocity during the solar maxima. And then this is for the solar minimum phase, where one can see that the velocity, the amplitude of the velocity has increased of these low degree global solar oscillation modes as seen in the GONG data. And we know that during the solar cycle, there is a mechanical and magnetic restructuring of the sun. And it looks like that restructuring of the sun inside is giving this kind of pattern of velocity flows. Not only the GONG Doppler or magnetic observations, as Frank has mentioned already, that in 2011, GONG added H-alpha observations, chromospheric observations, which is very useful for the space weather related activities. So in this study, the filament eruptions have been studied as a precursors to flare CME event, and the GONG H-alpha observations have been extensively used to explore the connection between the eruptive dynamics of filaments and initiation of solar flares and CMEs. And a total of 33 eruptive filaments for the period from 2012 to 2016 were studied as regards to time delay between CME onset and initiation of filament eruption. And this has been done by one PhD student working under Professor Nanta Srivastav. And the results obtained from this analysis would be useful for space weather assessment and characterization. And here in this panel, the mosaic shows the destabilization of a large filament as seen by the GONG observations, and then destabilization, and finally it erupted within a time period of less than an hour. And similar such observations have been used in this study. This study is related to the velocity field topology in solar active regions. And in this study, GONG Dopplerograms have been analyzed for several active regions during the descending phase of solar cycle 23. And the analysis shows the evidence of hemispheric preference in the kinetic helicity of velocity flows similar to magnetic topological parameters. That means the helicity is negative in the northern hemisphere and positive in the southern hemisphere. So that is seen in this extensive analysis. And one important thing what was observed in this analysis was that the magnitude of the slope of kinetic helicity versus magnetic flux. Here, this one in this figure, this is showing the magnitude of the slope of kinetic helicity versus magnetic flux with depth. And one can see that with the depth it is increasing. That indicates that the vertical vorticity is increasing with depth inside the sun. And not only the science, we also do a lot of public outreach activity with the GONG system. As you can see in these panels, we have a frequent group of students and teachers visiting from different colleges across India to the GONG facility. And we explain the working principle of the GONG, the instrument, and the science objectives of GONG to these students. You can see these students are of class 9th, 10th, whereas there are other students which are of higher grades. So we have a variety of students and teachers visiting to the USO. We show the MUST telescope and the working of the MUST telescope, the science, what we do with the MUST, and as well as the GONG and the e-Callisto, which was recently installed in the campus. So here, this is the outreach glimpses of outreach activity with the GONG system. And apart from the regular maintenance of the GONG, the USO GONG operation team also we joined the preventive maintenance team from NSO visiting Udaipur, and on annual basis in which everything in the GONG is checked whether it is working proper so that it runs smoothly for next 1 year. So here one can see this is for the last PM trip which happened this summer 2019. Here it is Sang who is checking the various details of the optics table here inside the center, and Dietrich checking the light feed assembly outside. And this is the complete team of USO who have worked with this PM team from NSO during this PM trip. So with this, I stop and thank you. And I also apologize for those if I have not presented any of the results in my presentation, looking at this short time. Thanks again.
Thank you, Brajesh, for presenting the summary of results obtained from USO, from the GONG instrument. This brings to the end of the talks today, and I thank all the speakers that have taken time out from their busy schedule and the time difference between India and US. So I thank you once again, and I hand over to Rohan for any question and answer session if there are. Rohan.
Yeah, thank you, ma'am. Before we move on to the next item on the agenda, I would like to convey all the congratulatory messages that we have received from all our colleagues in India. They have wished us on this occasion from Aries in Nainital, IA in Bangalore, from ISA Kolkata. But we also have some special messages from Professor Bhatnagar ji's family, from Anita Bhatnagar and Tripti Bhatnagar, who have wished us on this occasion. And we also have a message from Gupta ji's son, Saurabh Gupta. So thank you so much. I'd like to thank one and all for being a part of this event. I now request Professor Shibuke Matthew to present the vote of thanks.
So before concluding this section, concluding the Foundation Day celebration, let us thank all the speakers and organizers for making this day memorable. First of all, let us thank all the speakers, specifically Professor John Leibacher, Professor Jack Harvey, Professor Frank Hill, and Professor Alexi Pepstow from NSO. Thank you all for agreeing to share your thoughts, even though it is too late for you, late night for you there. And thanks to Bridge for presenting the science, which we carried out using the GONG data, specifically from USO. We would also like to thank Professor Anil Bharadwaj, our director, for his participation and also suggesting to take this program online. Big thanks to PRL Computer Center, especially Mr. Jigar Raval, Jaya Krishnan, and to coordinate, and Dr. Bhushit for coordinating the YouTube streaming, and also Demya and Naresh from USO for taking care of the network at USO. So nothing could have been possible without the initiation of Dr. Lohan Lewis and Nandita. Let us extend a big thanks to them. Also a big thanks to all the participants and online viewers. We hope you enjoyed the program, and let us conclude this program and sign off. Thank you. Thank you all.
Thank you, sir. Before we officially wind up, there is a small presentation prepared by Professor Nandita just to leave us with a nostalgic feeling. So here it goes.
Are you presenting, Rohan?
Yeah. So it should be up now.
Yeah, so I thought since many of the viewers joined late, which the presentation was showed on Google Meet, but not on the YouTube, I thought this was a nice opportunity for those who have missed watching it. I made a small presentation last night on USO and GONG, a long-term scientific partnership, and you see the two stalwarts from NSO and from USO who have built this partnership, who initiated this partnership. Next slide, please. So Frank was mentioning about the first helioseismology tutorial workshop. It was indeed held at PRL in January '93, and I think it inculcated interest in helioseismology and the young generation at that time, and some of them have taken up helioseismology as their career, and now have made big names for the country and for the field. Next slide, please. This is our team, Dr. Bhatnagar, Dr. Verma, Director PRL, and Julie Tumre, and Frank Hill, Sushant Tripathi, and myself at the tutorial workshop in PRL. Next slide, please. This is the meeting held after the workshop in PRL in Udaipur. So there was a combined meeting with the lecturers who gave lectures at the workshop in Ahmedabad, and they met here in Udaipur, and this is the meeting on the island in Udaipur. Next, please. This is again a group photo on the island on the same day. Next, please. So this was shown, this is the site preparation in 94-95, making the pad for GONG instrument. And I think the next slide was shown by some other speaker. Can you? Okay. Here is the inaugural day. We see Dr. Bhatnagar doing the inauguration, and John Leibacher taking a photo of him. And here are some other people, Professor Ambasta, Naresh Jain, and Pooja. Next. at the same place, our team, USO team, and with John, who was here for the inauguration in 1995. This is again Dr. Bhatnagar and Jack Harvey at Gong site. I think it's from 96 when he visited Udaipur in the Silver Jubilee workshop of Golden Jubilee workshop of PRL. Next, please.
Yeah, I have only these slides. Yeah.
Okay, thanks. Thank you.
What
So,
memory?
Great. So thank you all for participating in this wonderful celebration of USO Foundation. And I thank you all on behalf of PRL for joining us live from US. It must be late evening. And thanks to my colleagues from USO and PRL in active participation and conducting it in a very smooth manner. So thank you all, and good evening to all the colleagues from USO, and good night to everyone in USO and in US. And great day to all the colleagues of PRL.
Thank you, Professor Bharadwaj.
Bye-bye.
Thank you for
Bye.
your support.
Bye-bye, everyone.
Thanks, Frank. Thanks, John. Bye-bye.
Bye all.
Bye, Jack. Bye, Alexi.